Yes, this is Roland Fleiku. I'm the Senior Director of Broadcast Imaging here at Dolby Labs in San Francisco.
I know that you're not in control of just Dolby 3D. I know that you're in control of a lot more than just that, but obviously for the sake of this, we will focus on that. And recently I noticed that during, I think, is it NAB, James Cameron looked at the Dolby 3D system and was very impressed. Could you share his reaction and what was his thoughts? Because obviously he's seen Glasses 3D before, so could he share anything that he thought in terms of the quality of the Dolby 3D system? This is on a Philips display, right?
So this was at IBC, not NAB.
Sorry, IBC, yeah.
Just a few weeks ago. And yes, this was on our prototype display that is using both the Dolby technology as well as the Philips technology. So Dolby 3D is a joint project between Dolby and Philips Research, and the whole aim is to really advance the timeline and bring in the timeline for glasses-free 3D. So our whole point is to tell the industry glasses-free 3D at a high quality level that is ready for the consumer doesn't need to wait for another 3 or 4 years. It's ready now, and it can be put into products now for availability in the next year or in 2 years' time, rather than in 3 or 4 years. That's really our main point, and I think that message also resonated with our visitors at IBC, of whom James Cameron was one of them, and his perspective is, as I understand it, is that he wants 3D to succeed in the industry. So everything that can help that cause is a good thing. And it seemed like what he saw on our booth definitely contributed to that notion.
Well, let's talk about the Dolby 3D system, because even myself a little bit confused about what Dolby 3D actually means. I mean, I've read some articles. From what I understand, it's something that's display agnostic, so it can be on regular 3D TV and glasses free, right from a large sort of screen down to a smartphone, to do with your efficient encoding system. What I am interested to know is that you are pushing the fact that you are delivering a higher quality 3D, full HD to Dolby 3D enabled devices, but I'm still confused about how you can claim that when you're putting that onto a regular, for example, a passive TV or even a lenticular screen. No matter what encoding you're doing, surely you're still not going to be able to deliver full HD 3D on a passive screen or even a lenticular screen.
Right. So there's two technology components to Dolby 3D. So one, as you correctly mentioned, is the full resolution enhancement layer scheme that we developed on top of H.264 that basically packs the pixels that are today thrown away in the process of creating a side-by-side signal. Our encoding process packs those into a separate enhancement layer that only requires an additional 10% of incremental bandwidth to transmit and deliver and distribute the full HD signal, but doing that at the same time in a backwards compatible way. So the base is still a side-by-side or top-bottom signal as you have it today, and the enhancement layer, which is that extra 10%, contains the missing pixels, which then in an enabled device can be reconstructed to full HD 3D output. So whatever travels across the HDMI link when it comes out of a set-top box is the full 1080p left eye and the full 1080p right eye, that then gets sent to a television. And the television does its own thing. In the case of a glasses-based television, it's with an active shutter system, you get 1080p for each eye. On a passive glass system, you're right that with today's televisions that are out there is a resolution decimation happening in a particular direction. But in the future, with Quad HD panels, that will also go away. That limitation will go away. And then in the case of lenticular lens displays, what we are showing is really the value of of this full resolution signal in the case of a Quad HD panel behind the lenticular lens screen. And the lenticular lens that we are using in our prototypes, which is by no means the only one that this works with, but it's just the best one that we can find right now, is a fractional lenticular lens that's designed by Philips that really gives you back a much higher resolution impression than what you've seen so far in the past. So this is a combination of driving a Quad HD panel behind a fractional lenticular lens display and array, and the combination of the two does give you the notion of a full HD 3D video.
Okay, so at the moment, for example, Sky 3D here in the UK will broadcast a side-by-side signal, so it's automatically halved. Then on the passive screen, I'm guessing it's a quarter resolution per eye. With your system, you could potentially deliver, until we have full HD passive screens, an improvement of 100% to each eye. Is that correct? So you're able to put in two 1080p images through that one stream with the two stereo pairs, and it's up to the TV what it does with it, I guess.
Yeah, potentially that's correct. It of course depends on how you do the decimation. I mean, the passive polarizer displays typically decimate vertically. The side-by-side signal is decimated horizontally. So yes, in that case you would get a resolution gain back. Of course, if you're clever and you decimate in the same direction as in your transmission link as you are seeing on the display, then you don't actually have a resolution loss. But unfortunately, that's not the case.
Okay. I know in April you said that you were engaging some consumer electronics companies on the content side and broadcast operators and over-the-top content aggregators. That's, for example, a company that you can access content through online via connected TV. Can you announce any deals? And also, will you, in the short term, be able to introduce Dolby 3D not as an integrated solution, but maybe as a set-top box, or maybe license the technology into a 3D Blu-ray player on the consumer side? Have you made any deals, for example, broadcasters?
So there's nothing we can announce today. We're working with the industry in a very focused manner. And the use cases, as you pointed out, are those of streaming over-the-top content into a set-top box or into a connected TV, or broadcasting full-resolution 3D with our enhancement layer over cable or satellite or even terrestrial systems, depending on availability of appropriate decoders. Then the user will be able to benefit from the quality improvements. But as I said, stay tuned for any announcements. As I said, right now we're working with the industry, and as you know, integrating this technology into chipsets takes time. Sure. At the point, I can't really say as to when product will be available, but everything is looking very promising.
Okay, and just a very quick question: your system allows a volume control, a volume of 3D. Is that correct?
Yes. So one of the benefits of the Dolby 3D algorithm, when we come into the second piece of technology that I started to explain earlier. So the first piece is the full resolution codec enhancement. The second piece is the multi-view rendering algorithm that then is needed for glasses-free televisions to create the multi-view signal from the stereoscopic input signal. And as part of that process, you can do all kinds of things. Once you have generated a depth map or several depth maps, you can then use that information to control the intensity of the 3D effect or the volume of the 3D effect. And of course, using that same algorithm in a different way, you can do the same on glasses-based systems as well.
Oh, interesting. Okay, because I've always been surprised that hasn't sort of been with us for a while, because people like different types of 3D, don't they? And talking of that, so you've obviously squeezed. Am I correct in saying you've got stereo to auto stereo 3D conversion signal in there too? Is that right? You've got
absolutely. That's the stereo to auto stereo or stereo to multi-view, as we call it. So that algorithm is the key ingredient for the glasses-free displays that have multi-view capability. So that's what we were showing off at NAB and IBC and the 3D Entertainment Summit in Hollywood. Mm-hmm. And that is in combination with the full resolution enhancement, the two playing together really give you the best experience, and that's what resonated really well with the audiences at all of those shows.
Okay, so do you think you've cracked the stereo to auto stereo 3D conversion? Because I've seen some really bad examples. In the same way, I've seen 2D to 3D conversion real time pretty bad. So have you managed? Are you confident that you've managed to deliver a system that would be good for consumers right now? You're not pre-preparing anything for these shows, are you? Are you doing like a live feed from like the Astra demo channel or something?
So at this point, we are showing pre-rendered content simply because the FPGA implementation of our algorithm is not quite ready yet. It's going to be ready later in the year, but it's employing the same exact algorithm. And so we do think that we have a solution for the consumer device space, and the TV manufacturers are excited about the fact that there is a solution now that carries a very well-known brand and is backed by two significant companies and significant players in this field. So it gives the industry a lot of confidence.
Okay. Going to the broadcaster side of things, I know there is, you could argue, a competing platform called 5Tile by Sisvel Technology, who recently joined up with Triaxis. I think they were showing a few things at IBC too. That they've been around for some time, who are able to deliver 720p 3D backward compatibility. Dolby 3D is backward compatible. It's very, very efficient with streaming. One part of the question is they've struggled because they obviously will make money from license fees. It's a proprietary encoding system. Do you see that as a barrier to take up when the likes of Sky and even CCTV in China are very happy with side-by-side? I've completely forgotten the second part of that question, but maybe you could just answer that. Do you see, is it going to be a challenge to encourage people to take up something that will offer better picture quality when sometimes consumers don't even know if they're watching SD or HD, for an example?
So in our conversations with broadcasters and operators, it's very clear that they all see the current side-by-side transmission as the pragmatic first step, but they all are looking at the next step, which is to deliver full resolution. And the question is then, how do they best do this without compromising their existing transmission signal? Because there is definitely the expectation that you will have to, as a broadcast operator, have to continue to transmit side-by-side signal to your existing install base. But at the same time, you would like to augment your 3D transmission to full resolution. And our enhancement layer scheme, we think, is the exact right solution and the right answer for this, or to this question. And yes, you're right. The hesitation by the industry, which is quite understandable, to implement a technology that isn't standardized is definitely there. And so you will continue to see solutions that are based purely on proprietary standards or specifications. They will continue to struggle, in my opinion, and those that will go towards a standardization path ultimately will succeed, as I believe it.
Okay, but I mean, you're proprietary, aren't you? So are you saying that you see that as a difficulty for Dolby? I mean, how will you generate your funds? Is it sort of like the Blu-ray versus HD DVD battle, where you sort of get a license fee per, I don't know, transmission or box that is installed at a broadcast head end, for example?
No, I mean, in terms of the business model, I mean, you probably know how our audio business model works, and so our business model for imaging technology is going to be very similar. But it's also important to understand that our technologies in audio, they are, represented by standards and industry bodies, and so we are pursuing the same for our imaging technologies.
You were showing a 28 view screen at NAB, a 28 view screen. Do you believe that lenticular screens have a place in the future of glasses 3D? I did recently see stream TV networks that sort of been making a lot of noise in the media recently, who claim to have no transition zones, and they say they don't use lenticular screens at all. Do you see lenticular as a stopgap to another form of glasses 3D, or do you actually see lenticular as being a something that will be in people's homes? Of course, you've got the whole viewing angle issue as well. So where do you see lenticular screen on your roadmap for Dolby 3D?
So, I mean, as a first point of reference, Dolby 3D is display agnostic. So Dolby 3D works with any kind of 3D display technology, be it glasses-based, active or passive, be it glasses-free, parallax barrier, lenticular, or any other technology that may come into focus in the future. And right now, we just think that for larger screens, so not smartphones or tablets, but televisions, that lenticular offers the best trade-offs. And beyond that, there is the notion of switchable lenticular, where you can actually turn those lenses off to get, for example, full native Quad HD resolution for your 2D viewing experience, while when turned on, you get autostereoscopic 3D at HD resolutions. That seems to provide the best trade-off for the consumer, and that's what the industry seems to be pursuing right now. And it makes us very happy to see that there are solutions out there that are really practical and that provide very high-quality autostereoscopic 3D viewing experiences without compromising the 2D viewing experience.
So Dolby 3D will fit in, for example, 4K screens are coming out, 8K will probably be a broadcasting standard by about 2020. Dolby 3D is compatible with all this future of super high resolution content and displays. Is that correct?
Actually, Dolby 3D benefits hugely from these high resolution screens. So even if the content is HD, the pixel real estate that you have on a Quad HD panel is really important to enable to accommodate all these, 28 views or even, high number of views in the future, while retaining a significant resolution per view for the consumer, so that they get the notion of watching 3D in HD without glasses.
Before we just finish off talking about China for a bit, what evidence is there that glasses-free 3D will make 3D popular, more popular than there seems to be a bit of a hesitancy amongst the general public at the moment? You do have questionnaires, people say, I hate the glasses, but is there any evidence that 3D will take off in a big mainstream way without the glasses? You can look towards the Nintendo 3DS, for example, and the the LG Optimus 3D for not proving customer with general users, certainly the 3D functionality anyway. Do you have any evidence that this will push 3D into the mainstream?
So there's anecdotal evidence and there's consumer research. On the anecdotal side, you might have witnessed this yourself, the amount of interest that we were able to generate at both our NAB and 3D Summit and IBC appearances has been really phenomenal. I've never seen this many people consistently packed around a booth and a demo as I've seen with our Dolby 3D demo in this year. So this was already the first indication that average viewers are really appreciating what they're seeing. They like the fact that it's a very calming and pleasant 3D viewing experience. It's not exaggerated. It's not disturbing. It doesn't give people headaches. So all of this is very positive. And then on the actual factual side, data-driven side, we're about to conduct some consumer research in that direction to really understand what in particular it is that drives consumers towards 3D, or what it is that turns them off at this moment, to really understand whether it's the glasses-free aspect, which we believe it is, but there may be some other ancillary aspects that we may be able to take into consideration to further improve our product.